Okay, and as I said before, so today we're going to explain the concept of REST API, see a simple examples, which does not involve any database yet, and then we'll talk about how do you run or install MongoDB, and this can be potentially quite easy for some of you. But for this module, will require you to host the MongoDB database online. So instead of running on your own computer, we're going to using something called MongoDB Atlas, and which allows you to run a kind of instance of MongoDB server online, which will be used in the coursework, individual coursework. And okay, and so first, we're going to talk about briefly what is API. Okay, so and the things we're mostly interested in will be the REST API. But we'll start with the concept was the API. And so essentially it stands for application, I forgot now, and what is P stands for? Application something interface, application programming or programmable interface, something like that. But we'll start with a similar concept called an graphical user interface, or sometimes short for GUI or GUI. So that's the interface between the user and the software. So most of software will need a graphical user interface or GUI, and the exceptions will be the command line tools and like the Git or Node.js. We try to run these. We can run these on command line. So they also have a user interface. It's not graphical and it's mostly text-based, but that's an interface. An example of interface between two things. In this case, is between the user and the software. So the API, and which is application programming interface, and that's the interface between software. So that's for the communication between the different softwares. It's not between users and the software, which is the user interface. Okay, and the examples of the API including, for example, you can have the interface for the software that exists on the same machine. For example, the games and the graphics drivers, which allows you the games to use the features in the graphics card in your computer. That's an API provided by the graphics driver. And this API can actually also working for different software on different machines. So for example, you can have some code running on your local computer, talking to the API through API to some other code which is hosted on the server, which can be say in the cloud, hosted by Amazon or Google. And the main idea here is that the API, which is an interface between the softwares for them to talk to each other. Okay, and the other thing is, so the API itself is language independent. And here the language means programming languages. So when two pieces of software talk to each other, they don't have to be written in the same programming languages. So for example, you can have the server, which is written in Node.js, which essentially is JavaScript, but front end and different front end can use this service or the API. It can be written in JavaScript, but it also can be written in Java, Python, C, or any other languages, so long as the language can access an API. Okay, and for this module, we're gonna mostly focus on a JSON-based API. So the JSON will be the language that used to describe the API or for the communication of the data using the API. And so we can have a simple API. For example, it will take a time zone string and such as the location here says America, Los Angeles, and it will return the current time in that zone. For example, this might be the return, depends on what do you send to the request and to the API. This is what you get in return. Of course, the value of the return will change, depends on the actual time. And then the request might be something like this. And so obviously there's something before the slash as well. That will be the actual domain name of the server. maybe say slash time zone. That means this is one of the route you define, and this will be the parameters you set in to send to the server. You say the question mark indicates what afterwards is parameter. I'm gonna send the settings of this time zone I want to use TZ, something you have to pre-agree with the API specification, and say that the value will be American plus Los Angeles. And then you will get a response, something like this. And it's a simple JSON object which has two properties or attributes, time and zone with their own values. Okay. Um, Maybe in a sense, almost like you're querying a database, you send a query and you get a response, with the difference being the query you send is actually a URL and the response you get back is a JSON object. Okay, and then the applications or the software that want to use this API can run any platforms, and so long as they can communicate with this API, essentially has internet connection, can talk to this server where the API is hosted, and then they'll be able to handle the JSON response. So they know how to handle JSON, which is most of the languages. Okay, and then to use any API, and especially JSON API or JSON, and usually you would build a simple web page which uses the fetch we already covered before, and to send a request to the API, and then you will get a response back, which we're again seeing that already. So you'll get the promise which is created by the fetch request, and then allows you to do something, and after you get the response back. And because it's a promise, it will automatically wait until you actually receive the response before you do anything that you ask it to do. Okay, and then you can also build a mobile applications that can request the same API, pass the data, and display on the phone. So this is just an example. Say, once you had the API, it can be used by different software, can be a web page, can be a phone, or can be some other desktop applications. And the way of accessing, they can all accessing the same API, and the way of accessing it is actually very similar, even that in different languages. Okay, and then the API itself does not have to communicate using JSON. So, and they can use other data formats such as XML or even plain text. So this is just something you have to pre-design and say everyone using the API have to follow the same predefined, say, data format and the way to send query. Okay, and for this module or all the examples we use here, we're going to using JSON because that's has the best integration with Express. Express actually can handle other data format as well, but that will need extra plugins or and node packages to do this. And also JSON is a native and data format for JavaScript, which is what we're using to building all the apps. And also that's probably one of the most common ways to create and use API currently online. Okay, and we're gonna start with a very simple Express and power the JSON API. So this API will be created using Express in the sense on the backend, there's this service which will listen to incoming request and depends on the request it will return back certain responses. This will be mostly done using the route we covered before using Express. And in terms of exchanging data, we can all use JSON in these examples. Okay, yeah, I already mentioned. So on the backend side or the Express side, we're going to using middleware and the route to take requests and pass them. Okay, and then Express has certain building functions which are making sending response and much easier. For example, it can easily serving static files such as pictures. Okay, And we're going to have a very quick look at some simple APIs. And all it does is just generate some random integers. So when you send a request to this API, you would send two parameters. One is the minimum value, and the other one is a maximum value. And then the service will generate a random number between the minimum and the maximum value and send it back as a JSON object. Okay, and so just as before, and you need to create a package.json file. Just create this as a Node.js project. As for the backend for your server, which I'm going to do that now. What will be the okay? Let's say and okay, and so if you remember, we have two ways. You can either just create this package.json manually, or you can use the node init to initialize by answering some questions, and it will create this package.json file for you. So we're going to do that. Do the second one today. Let me see if we can go to the right directory slightly faster. Okay, and so instead of using command line, we're gonna just using Visual Studio Code. Hopefully you can see now. And using the built-in command line tools there to do this. Okay, and so currently I'm inside this folder called demo, and you can see there's nothing in there. I'm gonna turn on the command line inside the Visual Studio Code. And can you see the text okay inside the Visual Studio Code? Is that too small? Hello?
So a little bit bigger, please.
Still on a little bit bigger.
Thank
you. Is this okay now?
Yes, it's perfect.
Okay. Yeah. It's partly because of the screen. And oh, okay. And I can do ls, which lists all the files. On Windows, this will be dir, and you can see currently there's nothing in there. And then I can do node, which initialize a project for you. Ah, sorry, and it's npm. It shouldn't be node. I can clear that. Okay, and so first you enter the package name. This maybe thing. I call this API demo, and that's some version, description, entry point. Okay, instead I'm going to just call it app.js, so that will be your main file. I'm not going to do any tests or git yet. Okay, and so now a file should be created for you now. You can see the package.json, and if you open it up, it has these information in there. So I specify the name and the main file. Everything is using just as default values. Okay, and so we're going to use this and for our demonstration of the first simple API. Okay, so next we're going to create a file called app.js, and this will be the one that we'll use to actually write the express code inside. So we're going to create a new file. Oh, I don't want the folder. Okay, as I said, we want to create an API or a server that will return or take two parameters and then generate a random number between those two numbers. Okay. And so, yeah, this is creating the package.json file, which we already did. We already have the file. Now this is what the code would be like. I'm gonna just maybe type in these, and as I explain, as I type. Okay. So this first line I typed in just and kind of load the Express package or the external module for Node. So this is, you always need this because we want to, and using the Express, and then you probably need to install the files later on if you haven't had that on your computer globally. Okay, and the second line, just create an instance of Express and just call it app. Okay, app.get. Okay, so this is now creating a route, and as we mentioned before, this route only responds to GET request, which is a default request, and there's different type of requests which we're going to cover later on. Okay, and then so everything here is inside the GET and this bracket after the GET. So it's like a function, a lot of things. So first is a string. So that's one that this particularly route would request to, I would respond to. So it says it have to have the random and max. Okay. So this one is a text you need to include in your query string. So like a localhost / random. And if you remember, when you have these columns there, that means these are the parameters. So that's the name of the parameter. So by the name, we can guess that's probably should be the minimum value, and that will be the second value. And by the name, we can probably guess that should be the maximum value. So when you actually typing the URL in the server, and you would type in something like localhost 3000 / random, and then followed by two numbers, maybe say 10 / 20. This will be kind of string you're going to type in your browser when you're actually accessing. Okay, so this part now so far defines the path or the route, and then now we have the function which actually will do something with return some request or something else based on the input. And then just as all the, how do I say, route, you need to have at least the request and the result. Let me bend it. Okay, you need at least have this request and result object. So the request will including object would have all the information user sent to you. It will get automatically passed. For example, you would get what the min and max out of the request. And the results object is what you will send back to the user. Okay. So if we keep going, next part will be we're defining two local variables. Pass int. Let me close this one so you can see all the lines. Okay. So here I'm defining a variable called min just to store the minimum values user, and then this parsing is a built-in JavaScript or Node.js function, so you don't have to do required first before you can use. And this REQ refers to the request object we mentioned here, so that will be provided by Express and Node. And then here, so misspelled it, should be the parameters. So that's the name of the object, which can including everything about user incoming request. So that's called parameters. And then among the parameters, I want the value of here. So I say .m and in. So because I use the column, so it knows this, whatever follows is a parameter, and I can refer to that values using min. Okay, so this name here has to match this here. And for example, if you here is called, say, minimal value, and then here you have to type minimal value. Yeah, so these two has to always match. That's the point. Okay, and we're just gonna come back to what we did. Sorry, I'm gonna continue. And so here, these two just happen to be the same name. That's okay, but they don't have to. Okay, so once I define the minimum value, I can do the similar thing to store the maximum value. And I still get it from the request object, and then the params or parameters object. And this time I want to get the maximum value, which will be this one here in the incoming request. Okay, and then it's relatively easy. You could just send back a random generated number between these two values, which has a function in JavaScript can help you do that. But in this case, we're being kind of a good programmer. We actually do some error checking first. So the things we want to check is, in case these two, what user put in there, are not numbers, then we will return a number instead of try to generate a random number. For example, the user can potentially say typing something like local 103,000 and slash ABCD ASDF and then LKLJ. It's still possible. There's nothing to stop user to send this kind of request. But obviously, these are not numbers, and you cannot generate a random number between these two values. So we want to send the error message if that's the case. Okay, and so to do this is where this part of the code is for. And so it says if is NaN. Okay, so NaN stands for not a number. And then this tells you if is not a number. So basically this part says if minimum, which is what you get here, is not a number, or max, sorry, I don't need capital, max is not a number. So either of these is not a number, you would, so here we're using the RES, which is the result object, which is the same here. We're gonna set its status, and you have these different numbers, but 400, everything starts with 400 is an error, so that means there's error, and you would return back a JSON object, or you can send a text message as well. And in this case, we're going to be sending a JSON object, says bad request, and the return. Okay, and so basically this will give you the error code or the status code to the browser. And because it's 400, then browser would know that's an error. And then this one is the actual error message, and this actual text. And you can decide, bad request sometimes is not very informative. you can say either the minimum or maximum value is not a number. So that might be a more informative feedback, but basically the text what goes in here, you can decide. And it's very important to have a return here. And because you have the return, the function itself, this function will stop running and goes to whatever code after here. So it starts from here. Otherwise, it will keep going, do whatever the code below it as well, which we don't want to do, because in this case, we will stop running the generator and just send the response already. Okay, and then if it pass this check, that means both are numbers, and then we can actually generate a random number. So we're gonna just say result. Here I'm gonna use the mass. Okay. Okay, maybe let's do it this way. So first we're gonna use this mass.random function. So that's a built-in JavaScript function, and it gives you a value between 0 and 1. Okay, but here we want to have a random number between the minimum and maximum. So there are a few ways to do this. So what we're gonna do is we're gonna first times the difference between max and minimum. So this is kind of like increasing the random number. So if the difference between minimum and maximum is 10, then this will give you a number between 0 and 10. And if the difference is 5, and it will give you a random number between 0 and 5. And then we're going to plus minimum. Okay, so that means this way, it will always give you a random number between the minimum and the maximum. Okay, and then finally, we're gonna want to make sure this is a integer, because and previously when you generate mass.random, this one, and it's very rarely an integer. It's usually a decimal, a number between 0 and 1 with lots of digits after the decimal point. So to turn that into an integer, so I'm going to using mass.round. So that's the rounding up, and it will turn it's like a real number into the closest integer. Okay, and once this is created, then we can add this to the return. And again, we're going to return as a JSON. This time we don't need to send any status because we don't need to set any error code. We just say the result will equal to result. Why? Okay. Or maybe let's just say this is a just call it the result. Okay, and just need to be aware. And here, the first result and is just a text string, which indicates the name of this property is called the result. And this second result is actually this result here, which will be the numbers generated by this formula here. Okay, and then finally, we're gonna run the server. So you do app.listen, and then you set the port, and you can just say 3000, and that would work already. So that was starting the server when you run this app.js using Node. And you can also say give you something extra, so you're allowed to add a new function there, as we did in the lecture slides, just to show a message saying it is running. So have a simple function that will be run when the server is started. It will log a message. Okay, So this just give you a message. It's slightly nicer, so you know the server is started. That's all. Okay, and then I can run this now. Oh, I need this part. Let me turn on the the console. This one. And if you remember, and the way to start and the node, and you can type in node, and the file name in this case will be app.js. You can also say npm start, which will run the start script in your package.json, which we haven't defined yet. So currently, if you run, it will say you don't have missing script called start, and we're gonna do start, and you just type in what. Okay, and then now we define the start script, which will run this command. So using the npm start is the recommended way because you can put much more complex one here. And this is also later on when we're using hosting this and server online. This is how the online service would start your node server. Okay, and then we're now starting my server. Now you can see there's quite a few errors. Okay, and if you go back up, you can see the reason is being cannot find module express. So in the code, we request the express module, but we didn't install that yet, so we have to install that first. So the command for doing this, if it will be npm install express. And if you install this globally already, and they will be able to find it, and they will be able to, you don't need to install that for each individual project. Okay, we can do npm start again. Okay, and you can see it's fine now. It says and random number generator API started. And then I can go to a browser. I can type in localhost 3000. Sorry, it's very small. And if you only type in localhost 3000, and you would get this error message because in our code, we didn't define any route when the query path is just the root path, which is only slash. It doesn't have anything there, so it didn't get a response. To get any response, you have to slash random and followed by two numbers. Okay, let's say between 5 and 10. So sorry, this is very small. So what I'm typing in now is actually here. I'm typing in localhost 3000 slash random and slash 5 slash 10. And the last slash is optional. You can put in or not put in. Chrome should be able to handle both cases. And that's why I'm following this pattern here. So I say slash random and followed by two parameters. Okay, and then if I enter return, okay, so this is the response I got. And so I'm using something which allows you to parsing the JSON object nicely. So it would look like this. And if I turn that off, okay, for example, if I disable the JSON viewer, okay, and then do this same request again, and you will just get a result like this, which is completely fine. So in this time, okay, also the value changed as well, just because it's a random number generator. Okay, and also I can actually enter a wrong one, invalid request. For example, now I entering something like this, and the first parameter is still 5, but the second parameter is a string. And if I run this again, and you will get the error message says either the minimum or maximum value is not a number. So that means this part of the code, which is checking whether it's a number or not, is working properly. Okay, and so that's the very simple API I can show today. And I mean, to do a proper API, you probably need to do even more checks. For example, here you check whether these are numbers, and then you probably also want to check, for example, is the max actually bigger than minimum? For example, if you do a request where the max is actually smaller than minimum, well, it still get the results anyway. Okay, yeah, and so this is what it look like. So in this case, it enter the two parameters, which is 10 and 100. So you get a value between 10 and 100. In this case, it get you 77. Okay, so that's a very simple examples of API. And in most of cases, and what the API can do a few different types of operations. So these are called create, read, update, and delete, and which has a short name is just called CRUD or something like that. So it stands for create, read, update, and delete. So let's say if we look at a photo sharing app, and it may need all four types of APIs. So you can upload photos, which is the create part. You create new items or records in the database, or you can browse photos, which is the read request, which retrieve data from the backend. And then you can edit or make changes to the photos. And if you want to save the changes, that will be an update API, which changes existing data and in the backend. And finally, you might want to remove photos and from the website. And this is when you have the delete using the delete API. So usually you specify this by using the different methods in your route. So you're going to using instead of get is mostly for read, and then you're going to using the post, update, and delete. Basically change this for different types of API requests. We're going to see an examples very soon. And so these are different types of request, and is also sometimes called an HTTP verbs, but also known as the HTTP methods. The method is the formal name, and depends on the method, you can have different type of request. Even the request string is the same, they will be treated differently. So for example, you can have an app.post, and with the same string, then it will not be handled by this route. It will, because the method itself doesn't match. So the common methods are the get, put, post, and delete. So we're going to look at each of them individually. So the get is the most common one. That means you get something from the server. So this can be a page, can be a picture, or can be a request. You want to get a random generated number. Okay, and the important thing is that get method shouldn't change the status of your app, or more specifically, the backend status of your app. And so the other method might do, for example, when you do create a new record, then that changes the status of the app. The get method only read data or retrieve data from the backend. It doesn't change anything in the backend. And then, for example, if you do the same request 500 times, and the result should be never change, and at least the result should not be caused by the get request itself. And so in this example, and we have a random number generator, and every time you request this, you're probably going to get a different results. but this request change and is not generated by the get result itself, but not caused by the get request itself, but caused by the random generator here in the code itself. That's causing the change and not the get request. Okay, and the second type of method is called the post, and post is usually used to create things on the backend, and which causing a change on the backend. So you can post a new block entry, you can post a new photos, or you can post to create a new account on the website. Okay, and post is meant to create new records and not modifying existing ones. So that's what put is for. We're going to cover that later. And also, when you're using, say, for example, submitting a form, that's usually also a post request you get from the browser. So if you have a form on your app or on your page, and you click the button, and that will be automatically send a post request to the backend. Okay, and then the third one is the put, and the put is actually to update or change. So the post is to create a new items or new data entry, and the put is to change or update existing ones. And for example, if you have job profile online and you want to change it, and you would post those changes to make them permanent, essentially ask the server to save the changes. And similarly, you can put changes to document, blog entries, or pictures you have on the server. And you don't delete items using put. And this is what delete for, which is the last one we're going to cover next. And also the put is meant to change the record. And if the record doesn't exist, some server may create that record, but that's not always the case. This really depends on the backend. Some backend route will decide, okay, if you want to put something and does not exist, it will create that for you. For example, I think that's the behavior in MongoDB. And if you want to say modify a document which does not exist in MongoDB yet, and it will create that for you. Okay, and the last type of request is delete, which is probably the easiest, and it just removes something from the backend, or delete, so you can delete blog, delete photos, or delete comments. Okay, and so here we're going to see our second examples. For this one, we're going to create a very simple API, actually REST API, and it doesn't connect to any database yet, but it has the basic four types of request. So the get, the post, the put, and then delete. And because we haven't connecting to any database yet, it actually doesn't really do any changes in the backend. All it does, and is just sending back some some message. So just to acknowledge that particular type of request is received. Okay. Okay. So we're gonna create a new file here. Let's just say this is called crud.js, and we still need to request the express module require, and then we want to create an instance of express. Okay, and then now we're starting creating different route and routing each one for each type of request. Okay, the first one is the get, which we saw the most, And here, the particularly pass to retrieve it, just the slash, that means the root. That means you don't need to type anything. And in terms of the request and the results, the response, what it will do when it actually happens, it just send back a text message. So in this case, we're gonna use the res. Oh, sorry. So we're gonna using res object, which is the results object, instead of using the JSON as we did before, which sent back a JSON object. This case, we're gonna just use send, and in the send, we just send directly a text message. Okay, and so all it does is send text message says you just sent a get request, and we can do the same for post. Function, the request and result, and we'll say the result is gonna send. Ooh. Okay, and you probably can imagine we can do very similar things. And for the put and delete, we're gonna just type in, maybe I'll be, okay, so I'm gonna be a little bit lazy or save a little bit time. I'm gonna just copy paste. And this one, we want to do a put, so the response to the put. And finally, and this one will be delete. Okay, so now I have 4 routes to respond to 4 types of HTTP requests. And then finally, I'm gonna start. I'll just say console.log. Yeah. Maybe just call it CRUD API is running. Okay. And then, so that's our backend. And to start, we're gonna still use, now, gonna change the start script. So I was starting using the app.js. In this case, gonna try to start using the CRUD. The old one is still running here. Let me stop this one. Okay, and if we're still typing npm start, and this time it should run the CRUD API. And then if we go to my server or go to my browser, and again, so this will be a little bit hard to see now. If I type in localhost 3000, and it will say so you just send a GET request, and which matches this request, this one here. Okay, and then now comes to the other thing is in the browser, it's not possible to send post, put, or delete request. And you can't really say post localhost 3000. It will not run it. Okay, so this comes to the next part of the lecture slides, and you need some other tool to run this. And so to send other types of requests besides GET, so the GET is a default one, and any URL you typed in the browser is treated as a GET request. But if you want to send other ones, you need to use some tools. We're going to first introduce this one. We're going to introduce more complex one later. And this one is called curl, which actually stands for client URL. And I think it's pre-installed on all the operating systems, including Windows, Mac, and Linux. Okay, and then with the curl, we can actually send types other than just get. Again, get will be the default one, but you want to send, for example, a post or a, how do I say, put or delete, and you need to use this and slash capital X argument. Yeah. So I'm gonna using okay, just to avoid confusion, I'm gonna using my terminal window. Ooh, and is the text big enough in the terminal window?
It's fine for me. I don't know about others.
Okay, maybe one tiny bit more bigger. Okay,
One size bigger.
one size big. Yeah. Okay. And so first you just type in curl. Okay. And if you get some information like this, that means it's working. It says try curl -help for help or menu for more information. The way you need to do this is something like this. You have to say curl and then send to the IP address that you want to contact. Let me see if I just type in localhost 3000, and you can see that works even without HTTP comma // and you can see this text here is what we created here. So when user has a get request, that's what you get in response. Okay, so that's not particularly interesting. We can do that in the browser. So what we want to do is to change this into different requests. Okay, so for example, we can do a put or post request and using the hyphen capital X. So let's do this now. I will say curl hyphen capital X. Let's say po. Okay, let's do put first. Still localhost 3000. Ah, it doesn't work. So I have to use capital put. Okay, okay. So you have to use capital. So specify the type of method, and then this is the URL you want to access. And you can see you get the response, say you just sent a put request. And you can do the same for post, and you should get the response back. And you should, if you do delete again, we'll get the response back. Just to make sure it's all capital, and that seems to be what the curl, at least for the Mac version of the curl. And so the curl itself is almost like a text-based or command line based browser. So you could potentially do something like this. You can do and curl. Okay. So first I'll demonstrate. You can also do get this way as well. You can. So this is the same as the first one we did here, which without this. And so you can specify I want a get, and you should say get response back. Say you just send a get request, or you can. Other thing is curl is almost like a command line or text-based the browser. You can say curl. Okay, I want to. Oh, that basically means I want to get a response from this URL, which is Google. Usually, you should type that in, and this is what you get. And if I type in the proper URL, and you can get all these, which is essentially the HTML code, and that would display in your browser otherwise, showing the Google page. Okay, so that's what curl is. Okay, so as I mentioned, we have these 4 operations, the CRUD, they create, read, update, and delete, and they match to these 4 type of HTTP methods. So the create is mapping to post, which is creating new items in the backend. The read is mapped to or get, which is read some data, retrieve some data from the backend, does not make any changes. And the update is the put, which make changes. So that data should already be there. And finally, the delete corresponds to delete, that just remove something from the backend. So the CRUD will be mapped to post, get, put, and delete. So that's how you will do it. So later on, we're going to actually create actual REST API interface using these different routes, depends on the HTTP method, and communicating with the database to actually insert or retrieve or update or delete records. Okay, and talking about the database, we can actually now have a look of MongoDB, and which is what we're going to use as a backend database for the lectures and all the coursework. And so why we choose MongoDB? Because it's designed to support JSON data natively. So unlike, say, MySQL, which is not really designed or not initially designed for JSON data. And most of you would already learn that in the second year, or some experience with that in the second year web development module. And so we're going to just, or actually today, going to have a quick review on the MongoDB. We will not be able to cover all the details. For example, how do you write a query in MongoDB? I'm going to show you how to just using a online version or online hosted version of MongoDB, which are going to be used later on in the coursework. Okay, and if you need more information on how to use MongoDB, and I would recommend have a look of the official documentation. I really should. It covers the basic ideas. What is say JSON database and how to do basic things in there. Okay. Okay, and there's a few concepts that's important. So this is part of our quick review of MongoDB. And first one, you need a server. And a server would have many databases in it. And then you would usually have one database for one application. So for example, we're going to do this online web store application, and it would have its own database in one server. Okay, and then to talk to the server, essentially, and communicating, either saving or read data, you need something called the drivers, which allows you to talk to the database. And then each language would have its own different programming language. So for each programming language, you have different drivers. So we're gonna using the driver for Node.js, but also there's there's driver for Java, for Python, for C, etc. Okay, and then for each database, you would have one or more collections. So the collections is like the tables in a relational database. And then within each collections, you would have documents. So the documents is like a row in a relational database. So if you look at looks something like this, and maybe this will be each application. It has own database, and the database is actually also hosted on a server. And within a database, you can have different collections. These are like different tables. You might have a collection of all the products on your store, another collections for all the users, and maybe a third collection of all the orders user made. And then within each collection, you have different documents. These are like the rows. So if this is a product collection, and then each document is a JSON object which has information about one product. For example, the name of the product and the price and how many we have left, etc., etc. And then here you have, if you have 3 products, then you have 3 documents, and if you have 10 products, then you have 10 documents in this collection. Okay, so these are the different terms you need to understand. So you have database. So first you have the server or application, and then database, collections, and then finally documents. Okay, as we said, and we're gonna using an online version of the MongoDB, so you don't have to run or install anything on your own computer. From my understanding, in the second year module, you download a local version of MongoDB to use for your coursework. Is that correct?
Yes, sir.
Yeah, okay. So this will be maybe new to some of you, but this is also allows you to have your entire app online later on. Other people can actually using it. Because if we use a local database and then later on we're going to have problems, for example, when your code, the front end is hosted on the GitHub pages, it will not be able to access or have difficulty. It's possible, but not so easy to access the database which is running on your laptop or a PC. And definitely other people will not be able to use your app because they cannot access your PC anyway, unless your PC is running all the time and open the port allows them to access. Okay, anyway, so just back to this. So we're talking about something called Atlas, which is provided by MongoDB. Essentially, it runs a MongoDB on a remote server, and then you can just use it as if you installed similar way as you installed it locally. And there's a little bit extra setting up and you need to do. So this is how we're going to use for this module for the coursework. And so first you need to create an account. And so this is an account for MongoDB. Oops. So if you don't have an account for MongoDB yet, and you would look something like this, and so I guess creating an account is straightforward. You either create a using Google or using an email address. I can't remember which one I use now. And I think I probably already had one. Okay, so because I already had one, so I can't demonstrate to you again what it looks like. But after that, and it would ask you, the first time it will ask you to choose one of these options. So we're going to choose the one which is called the starter cluster, which is free option we're going to using. And it has limited resources, which we're going to see a little bit more details on the next slide, but that's more than sufficient for the module coursework. Let me see if I still got option to do that now. Yeah, so because I already created my account, so it's, and you probably had the option here, so it doesn't allow you to change the tier anymore. Let me see. Nope. Okay. So yeah, I don't think I can show you this page anymore, but essentially it'll give you an option and just choose a free one for this module. Okay, and then you need to choose the server you're going to be using or the backend setup. So this is like a virtual computer that's running in the cloud. And the most difference will be in terms of amount of the RAM you have and amount of the CPUs you have. So in this case, only the first one is called M0 is free. So that's only one we will, I mean, that's almost, and that's enough for our purpose. And so it will say you have half a gigabyte or 512 megabyte of RAM, which is enough. And this is shared. That means you shared with other people in terms of actual physical memory, which is not critical in our case. And then also the CPU itself, which is virtual CPU, is also shared with other people. That means on one physical server, there's multiple database running. They all share the same CPU and memory, but that's okay. That's enough for us. So just choose this one, which is a free option. Okay, and then you have to create a cluster. And so cluster is means a group of MongoDB servers. So actually MongoDB allows you to increase your performance of your server by running multiple server at the same time. And if you have some very time-consuming job, it can be split between the servers. Okay, and just create any server. But in our case, we're going to using a cluster with only one server. That's all we're going to need for now. And then you create the cluster. Okay. Now you should see an interface something like this, which is, or something like this. And then the first thing you need to do is to allow access to your database. Okay, so by default, Atlas only allow access from certain IP addresses. So basically, and it will say, okay, for example, here, when we running a server, and it will receive a request, and it will check the request IP address of where the request coming from, and only a listed number of IP address will be allowed to access the database. So that's a security feature of the MongoDB cluster. And so you need to click network analysis, and then it will see a list of IP address that will be allowed to access the MongoDB server. And because it's the first time, you wouldn't have anything there yet, not like me. And you need to click this add IP address button. And then you need to type in your own IP address there. And you can add some comments as well. And then click confirm. Okay. So, and here, assuming you will be accessing the MongoDB database from your computer, then you need to find out your public IP address of your computer. So that's basically the IP address that the MongoDB server would see when you try to send a request. Okay, and the easiest way to find out your IP address is just typing my IP address in the Google search bar. So if I go here, and if I now type in my IP address, and then Google will tell me my IP address is this. Okay, so then you just need to copy paste and add it here. For example, I say, okay, a comment say this is my home IP address, and I confirm. Yeah, so it's already here. You can see it says home IP address. And then only after that, I can access the MongoDB server from this address. So if you say change your IP address, and you need to change the settings as well in the MongoDB and Atlas, and otherwise you will not allowed be to access the database. That's basically a security features. And if you, for example, if you go to university or you go to your friend's house or your parents' house, you would have different IP addresses. Then you just need to do this again and then add them to your allowed network access address list. Okay, so this address is only needed when you try to access the database through an API. So for example, if you just want to log into the Mongo database web interface like this, you don't need to put the IP address there. Okay, and then next, let's cover briefly in terms of creating database. And if you remember a few slides back, for each MongoDB, you have Mongo server, you have databases, usually one per application, and inside you have collections and documents. So we're going to try to create a database first. Okay, and again, so in the secondary module, you might use some front-end tools like I can't remember, Robo3T or something, or even just using the command line, just Mongo command line tools to connect to your database. And that's fine, you can still use it. But in this module, we're going to just using something called a campus, and which is provided by Mongo as a way to connect to database, and also as a way to connect, say, to create connections and documents. Okay, and to find out how to connect to the online database, you go to the cluster and then choose connect. And you choose connect cluster. Okay, and then you go to the next page. Okay, at the first time, you will be asked to create an admin user. Okay, so this is the admin for the database. Just as if you install a MySQL database, you need to create admin user. And that's different from the Atlas or MongoDB account. So the first account you create a few slides back. This one you created to access Mongo website or the Atlas website. And this is the account which you created to access the database. So if you remember, and maybe in the second year, you don't set any username or password, so you can just access directly to the local MongoDB. But here you have to create an admin username and password. So the admin user basically means the user has access to everything in the database. So later on, when you connect to the database, you need to provide the username and password in the connection. Otherwise, it will not be able to access the database. Okay, so that's basically the second layer of security. So what we did here is the first layer of security, so allow access from certain IP address. And once the IP address is allowed, you still have to have the right username password to access. Okay, and then you can choose the connect cluster option, and then you should see something like this and a few options. Essentially, it just provides you extra information, what you needed in terms of connecting to the cluster. It has different ways, and you can connect with Mongo shells. So these are Mongo command line tools, but that requires you to install Mongo and shell the command line tool locally. And in this case, we're not going to install that. I'm going to install MongoDB campus. And later on, we can actually also connect with your application. This is like using the REST API, using the Node drivers. That's going to cover later on. But today, we're going to just look at this part, which is say connecting using Mongo campus, which is the last one here. Okay, and then that will be the next page. And you would have the options to choose either I do not have MongoDB campus or I have MongoDB campus. The first time, most of you don't have MongoDB campus yet, and then you just choose one of the versions. So you can install either the Mac OS versions, or you can choose the Windows versions or Ubuntu, other different versions. And this is just similar to any other software. You choose download installation file and then run and install it. Okay, and once that is done, and you need to copy this part. So just click the copy line, and this is the URL that you need to enter after you install the MongoDB campus to connect to your server. Okay, let me see, did I? So I assume now you already download the file and then run install, and when you're starting the MongoDB campus, it will ask you to enter your connection string, which is what you copied from here. So these lines will be different, depends on your own account. You have a unique URLs and the password. And also the other thing important is here. Did I have? Yeah, it's okay. This is just still loading, and it's a bit slow today. But you can see here, this is so basically this part is the username and password you created early on. So remember here, it asks you to create a username and password, and this is what you need to put in here. So by default, it shows the username for you, but the password it will not show. So this part, you need to replace that with your actual password. And so in the actual, where's the, it didn't show here. So that's the interface. You're gonna see. I'm gonna try to make it a bit bigger here. So this is what the campus look like, and you need to copy paste your URL string from here. You just click the copy button and you paste it here, and then you then choose connect. Okay, and then here you need to replace this part with your actual password. Okay, and so if you type in the correct password, so this is my previous attempt. I already done this properly. I already tried it once, and this is what you will see. That means you already get into the database, now successfully logged in. And you will not see web store, but you should see admin, config, and local. These are three default databases created by MongoDB, just as you would see if you install them locally. Okay, and then you should see this, and then you can create new database for your app. You can call it different names, and just click the create this database button here. And then after that, you can create collections and insert and documents or JSON objects into collections. And all these can be done just through the interface. So for example, I already create something called web store. And then inside the web store, I created a collection, or you can just click create collection here to create more. And inside the products, I currently have some records as well. But if you want, you can also add data. You can just insert documents and you can type in JSON objects manually here. Okay, so this will be the way to recommend to including the data you need for the coursework on this module. And then later I'm going to do this programmably as well. You can set up the APIs and you can install the information into the API. Oh, sorry, install the database through API, the post request. Okay, and that's all I want to cover today. And so in terms of reading, so that's the chapter 8 of this free book, which talks about the different REST APIs, the different type of HTTP methods, and then later on the create, update, and read and delete request. And also useful is just have a look of the getting started with Atlas documentation. Again, then it tells you on how to create an account and deploy a free tier cluster, very similar, and allow you access to different IP addresses, etc. Okay, and that's it for today. How do I stop the recording?